Alright, in the last video we talked about solving quadratics and solving polynomials by looking for a greatest common factor first. And greatest common factor is always a good place to start when you are looking to solve polynomial equations. Today we're going to talk about solving quadratics by extracting roots. And extracting roots is a very helpful method if you have a binomial, so if there are two terms, and specifically if it is a term squared, and then let's say a constant term, like 55 is equal to 0. So when you have two terms, you can look for a GCF, but x squared and 55 don't have anything in common. And instead of trying to maybe apply some of our special factoring, which we'll work on later, you can isolate your squared term, so get the x squared by itself, then take a square root of both sides, and simplify your radical using your properties of square roots. So to practice that, if I look here, everything's set equal to 0. I have a squared term and a constant term, so I'm going to isolate my squared term. Then I can take a square root of both sides, so x equals plus or minus the square root of 32. Well, the square root of 32 is 16 times 2, and the square root of 16 is 4. So x will be equal to plus or minus 4 root 2. Final answer. Alright, moving down. Looking here, I have a squared term and I have a constant. Please note in both of these we didn't have a difference of squares. Okay, 32 and 5 are not perfect squares, which is why it didn't quite break down like the special products that you had on a previous video. But here I'm going to isolate my squared term, equals negative 5, take a square root, x equals plus or minus the square root of negative 5. If you remember from previous classes, taking a square root of a negative number comes out as an imaginary number. So we take an I out from underneath, and then the 5 stays in place. So no, this does not have a real solution, but it does have two imaginary solutions. Just to review that a little bit, when you take the square root of negative 5, it's the same thing as the square root of negative 1 times 5, which is the square root of negative 1 times the square root of 5, and the square root of negative 1 is defined in mathematics as I, and then we still had our plus or minus from taking the square root. Alright, this one, I have a squared term and I have a constant term. Well, this time it's not set equal to 0, but watch what happens if I move it so that it is set equal to 0. I still don't have a greatest common factor. Now, you could, if you wanted to, FOIL this all out and then get a trinomial and then try to factor it back down or use the quadratic formula. But the fact that we have a squared term, even though it's a squared binomial, we have a squared term and a constant, means we should be able to use our concept of extracting roots. So from here, I can just take a square root of both sides. I'll be left with x minus 5 equals plus or minus root 30. I want to get x by itself, so we'll say x equals, I'm going to add 5. And the square root of 30 does not break down using any perfect squares. So we don't have a 4, a 9, a 16, a 25 that goes in there nicely. In which case, this is your final answer. Alright, and then our last example for extracting roots. We again have something squared, a term with a 2 on it, and a constant term. So we're going to move things over to isolate our squared term. So I'm going to say 4x squared equals negative 81. X squared equals negative 81 over 4. Take a square root of both sides. X will be equal to plus or minus the square root of negative 81 over 4. Well, again, applying properties of square roots, we know that the square root of 4 is just 2, so that's going to be our denominator. The square root of negative 81, well, the square root of negative 1 is I, and the square root of 81 is 9, and then we have our plus or minus out in front. So don't forget, this is just a little bit reminder for you. When you take the square root of a fraction, you take the square root of the top and the square root of the bottom. When you take a square root of a negative, you can pull out that I as part of the imaginary number and how we represent that. Alright, that's it for extracting roots.